15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you so much for joining us on this, the 190th edition of the Space Nuts podcast. My name's Andrew Dunkley, your host, and with me, as always, the long-suffering Professor Fred Watson. Hello, Fred.
Yeah, I do. I suffer all the time.
Yeah, once a week at least.
Once a week, that's right. No, I'm fine, thank you. And suffering's not something that I do that much of, although you never know, it might be down the track.
Oh, well, let's not go there.
No.
As the famous Fred Watson always says, I'm not going there.
I'm not going there, that's right.
I think I'm the person who forces you to say that more often than most.
Yes, you are. Yes, that's right. But that's all right. One has to use these expressions sometime, and I'm delighted to be able to use it on Space Nuts.
Fair enough. Okay, today we've got quite a few things to talk about. The New Horizons probe has sent back some data, or they've analysed some data from it, which has basically written off one planet formation theory, which is interesting. It's good that we can write something off. I think that because it whittles down possibilities. We're also going to talk about something exciting that made the news this week in Australia, and that was the official opening of the Australian Space Agency. Woohoo! And both people have got a desk each, which is amazing. I didn't think the budget had stretched that far.
Eat your heart out, NASA.
Yeah. Also, of a similar ilk, Virgin Galactic has moved operations into their spaceport, in fact, at New Mexico. Fred's been there. He'll probably mention that. And we've got questions from Mark Mobbs about the size of the universe. Mark, it's this big. There, that's answered. And Bob Brown, not the politician from Australia, I'm guessing. What or where is space? That is a rather fascinating question when you really nut it out. And plenty more. We'll do a bit of spruiking about this, that and the other as well. But first, Fred, let's talk about New Horizons, the data that they have analysed suggesting that one planet formation theory is a write-off. We don't have to think about that anymore. Plasticine has never been used to make planets.
No, that's right. Well, I thought it was super glue, but plasticine's as good at bonding as any. Yeah, so this goes back to an old favourite of ours. We haven't spoken about this celestial object for some time, but last year we certainly did because of the flyby of what was then called Ultima Thule at the beginning of last year on the 1st of January. And we saw an image of something that looked like a snowman. This is, of course, an object 6 billion kilometres from the sun. It's in the Kuiper belts, that region of space beyond the orbit of Neptune, and looked like a snowman. But some of the later images that were returned from New Horizons showed that it actually wasn't snowman-shaped. It was two pancakes side by side, basically two flattened discs, one slightly bigger than the other. And joined together just as though they'd been placed side by side and stuck together where they contact.
With superglue.
With superglue, that's right. The whole thing, rather than plasticine, the whole thing is 36 kilometres long. And the reason why everybody wanted to look at this, and New Horizons was guided to this following its encounter with Pluto back in 2015, the reason is that this represents, one of the building blocks of the solar system. It's part of the debris left behind during the process of planet formation. It's probably made mostly of ice, very strong icy component. It will have dust in it as well, though. And the analysis that has now been revealed and basically released in scientific papers comes about. It's more than a year after the flyby, and that's partly because these things take time to analyse, but also, of course, because New Horizons is so far away, the bandwidth that we receive from it is really slow. It's dial-up mode bandwidth, very slow data rates, and so it's taking...
Like Australia's NBN.
Something like that. That's right. A little bit better, actually. So the data have taken a considerable length of time to get back to Earth, probably most of last year. But an analysis has now been done by a number of different groups who have looked at the structure of Ultima Thule. But I should have mentioned that it now has a proper name. It's called Arakoth. Ultima Thule was always a temporary name. It just meant the furthest object that you could think of. Arakoth is its new name, which comes from the, I think it's the creation mythology of, I can't remember where, I think it's a North American indigenous creation mythology. If I remember rightly, I might have got that wrong. Never mind, that's all right. It's an object of great interest. And now we believe it has done exactly what you said at the beginning, which has knocked on the head one of the two principal theories of planet formation, which leaves the other one, and it seems to fit the bill perfectly for the other one. So what are these two theories? Well, when planets are formed, they basically form out of the disk of dust and gas, which swirls around an infant star. So our sun, 4.6 billion years ago, was an infant star with this what's called a protoplanetary disk around it. And the basic theories have been similar in some ways, but there's the difference between them is really in terms of the violence within which the building blocks interact. So the earlier theory, which actually has a posh name, it's hierarchical accretion. And hierarchical accretion kind of tells you what it's about. It's a hierarchical process. You build things up and they crash, and then you build more things up and they crash. So they all start off, of course, with dust particles sticking together, a bit like the fluff underneath your bed.
Or in your belly button.
Well, that's right. Actually, they're not quite as... The belly button fluff is a little bit more dense than the underbed fluff. And that's partly because there are different physical processes in play. What sticks these particles together in the very earliest stages of planet building is electrostatic forces. They kind of come together and join up electrostatically. But eventually, the dominant force is gravity. And so this theory, basically the hierarchical accretion theory, says that particles stick together, they get ever larger, they collide, they stick together more, and eventually you get these things called planetesimals, which are more or less the size of Ultima Thule or Arakoth, several tens of kilometers across. Those things, the old theory says, okay, you get these things, and then the planetesimals themselves collide quite violently and actually sort of blast themselves to pieces, and then all the pieces re-stick together again. And that is the theory that really is not supported by Arakoth, because the alternative is that you've got streams of what you might call pebble-sized particles. So the dust grains stick together and grow to things the size of a pebble. But these are all sort of moving together in streams in orbit around the infant star. And basically, the clouds that are moving within these streams essentially just collapse themselves under their own gravity. They don't sort of go through a phase where they're growing and then they all smash together. They just simply grow. Yeah. So you've got this planetesimal, which is made of pebbles that have all been in the same part of the dust cloud around the sun, as it is in our case. And that's essentially supported by Arakoth, because, first of all, the main point about this theory is that the interactions between the particles that are making up the planetesimals are very gentle. They're not violent collisions. They're gentle interactions. And that is supported
more like putting together Lego rather than smashing mud into itself.
That's right. Yes. Yeah, exactly so. You're sticking Lego together. It's a good analogy, except that there aren't spotty lumps on the side of all these bits and holes that you can stick them into. But the reason why Arikos supports that view is its structure. You've got these two pancake-shaped objects side by side, which have come together at a very, very gentle rate. They're described by some of the authors as they basically kiss together. It's such a delicate interaction. One of the scientists who's worked on this work says that if there were spacecraft, there would be docking. There is no indication that the merger was violent or catastrophic. So you've got this sticking together. There's another point about this as well that again suggests a great degree of stability in the early solar system, and that's the fact that these two pancakes are edge to edge, so they're both lying in the same plane. Essentially, it's as though they were flat on a table. That would not have happened accidentally, but if they'd been in orbit around one another for a very long time, then you would get this alignment of their principal planes. They would align in the way that they have. So once again, it speaks of things happening in a very, very stable way. And finally, another paper, it's actually a different set of research, but it points out that the imagery we now have back from New Horizons of this object show it is incredibly uniform in color and composition. It's not it's not an object with great variations in its color, in its shading, and things of that sort. And so what they're saying is, once again, that points to a uniformity of the objects that made it up, the pebbles that basically went into producing this really remarkable-looking celestial object. All the scientists involved with it are very excited, none less than Alan Stern, who you will remember is the principal investigator for the New Horizons mission. He was in Australia, I think, a year or two ago. Yep. We got to chat with him. Great guy, full of enthusiasm and very, very interesting to speak to. But he has said, in throwing away the hierarchical accretion model, this one with all the collisions, he says, we as a team cannot imagine how hierarchical accretion could have created the Arikos that we see, he says. So that kind of knocks that on the head. But he also says that they're looking for a new target beyond Arikos for New Horizons to visit. He says, we've got fuel left in the tank, the spacecraft is healthy, and we have power to run 15 years. Our greatest ambition is to find another object that we can fly by. And that will be fantastic if they can do that. The problem is these Kuiper Belt objects, these objects deep in the solar system, are really relatively small. Now, Arikos is 37 kilometers long, but it's 6 billion kilometers away. Yeah. So it is not an easy task to find it. It was found by the Hubble Space Telescope, if I remember rightly. So we're going to be searching for other possible target objects out there in the depths of the solar system, and it will be difficult because they're so faint, so small.
Well, is it possible, I don't know if the timing will work, but is it possible that the James Webb Telescope might be able to find something?
I think that's kind of where I was going. Yes, that's right. So you're right on the money there, Andrew.
Just for once.
So I'm not saying I'm not going to go there, because that's exactly where I was going.
There you are.
And in fact, as we refine some of the technology on the ground-based telescopes, that will help. I think the James Webb will be the one that will be used, though, to look for the next target of opportunity for New Horizons. As Alan Stern says, they've got power for another 15 years, so you've got a little bit of time in which to search for something suitable and identify it and work out whether you can change the course of the spacecraft to pass it. So the James Webb Telescope, hopefully launched next year, I think. Take a little while to get it in train, but this might be one of its first missions to scan the outer depths of the solar system.
Which means the people working on New Horizons are going to get really good at dominoes, waiting for that thing to come up.
Or Lego, perhaps.
Or Lego, yeah. No, I think you have to be a kid to be good at Lego.
Yeah. That's right.
All right. Well, that's fascinating news. So we can write off that hierarchical accretion theory.
It's in the dustbin, or as we speak.
Yes, because of
It'll
dust.
probably come out again. It'll be something else that turns.
Well, yeah. They'll find another rock and go, wait a minute.
Wait a minute. Yeah.
All right. You're listening to Space Nuts. Andrew Dunkley here with the Professor, Fred Watson. Let's take a break from the show and hear a word or two from our sponsor, Grammarly. Now, I have to say I'm a big fan of Grammarly because I've been using it for a few years now. Very helpful for authors, but also really good for everyday life. They've saved me on a few occasions, particularly with spelling, but also with a few issues that didn't quite make sense. It's built by linguists and language lovers, and Grammarly's writing app finds and corrects hundreds of complex writing errors, so you don't have to do it yourself. Word by word, day by day. You can easily copy and paste any English text into Grammarly's online text editor, or just install Grammarly's free browser extension for Chrome, Safari, Firefox and quite a few others. Grammarly's algorithms flag potential issues in the text and suggest context-specific corrections for grammar, spelling and vocabulary. Grammarly explains the reasoning behind each correction so you can make an informed decision about whether and how to correct an issue. Grammarly helps you write mistake-free Gmail, Facebook, Twitter, LinkedIn, and nearly anything else you write on the web. For you, the listener of Space Nuts, Grammarly is offering a free download of the Grammarly software. So if you'd like to download Grammarly today, go to getgrammarly.com/spacenuts. Again, that's getgrammarly.com/spacenuts to download Grammarly for free and let them know you came from us. I'll include the link in the show notes as well. And now, back to Space Nuts.
0G, and I feel fine.
Space Nuts.
Now, I'd like to shout out to our patrons who have joined us on patreon.com/spacenuts for supporting the podcast. Had a few newbies join us in the last week or so. Thank you for that. Thank you for supporting our podcast financially. And it's not expensive. You can sign up for as little as $3 a month, US that is. So in Australian dollars, that's about $5,370,000. No, it's not quite that much. But if you would like to be a patron, you'll get a commercial-free edition of the podcast. You'll get it early and you'll get bonus material, all at patreon.com/spacenuts. Now, Fred, we are going to talk about a couple of things involving space agencies. One is the Australian Space Agency, and then we'll get on to Virgin Galactic, because they've all taken up residence. The Australian Space Agency has been officially opened.
Indeed, it has. So the Space Agency itself has been operating now for 2 years, I think, thereabouts, maybe 2.5. But it's been based in Canberra in temporary accommodation. In fact, it's been in the building that I work in when I'm down in Canberra, the Industry House, which is the home of the Department of Industry, Science, Energy and Resources. And that was always a temporary temporary accommodation. And a year or so ago, there was a invitation for letters of interest about where the Space Agency should find its proper home. And a number of different states and cities vied for that honour. And in fact, the outcome was that it basically has gone to Adelaide, which is the capital city of South Australia, one of the states of our great nation.
Yes,
so
located in the bowels of the continent. No, I'm kidding. No, I've actually never been to Adelaide, so I
Really? Have you never been to Adelaide?
never been to Adelaide.
You missed a treat. It's a lovely city, Andrew.
I've seen it on TV.
Yeah. No, it's a lovely city.
Usually when they're panning the cameras from the light towers at the cricket. That's all I've ever seen of Adelaide.
No, there's a lot goes on in Adelaide. It's it's well worth a visit. The City of Churches, it was always called,
Yes.
but it's also certainly now for anybody who's a space fan, it's got big attractions.
Yeah.
Adelaide got that got that honour of hosting the Australian Space Agency, partly because of a long history of South Australia being associated with space. I mean, I remember when I was a kid growing up back in the 1850s, well, maybe the 1950s. If you talked about space, even in the UK where I grew up, Woomera was the name that came to mind. Woomera was a part of South Australia where tests were carried out to launch rockets. And a lot of British rockets, when the Brits used to build rockets, they were actually tested there at Woomera in South Australia.
And for those who want to know, Woomera is an Aboriginal word meaning basically a spear thrower. They used to have a device they could rest the spear on, and it gave them much more leverage and range and power to throw a spear using the Woomera. And therefore, that's why we called the rocket range Woomera Rocket Range.
Yeah, and so there's still, I think there are still artifacts from that era there. But the association with space, I think, still continues. There are organisations within Adelaide already which have a space focus, and several space industries are based there. So it was a natural choice that the space agency should go to Adelaide. What has now happened is that their new building has formally been opened. It's at a place with the slightly uninspiring address of Lot 14. Lot 14, I think, it was a hospital at one stage, which has now been refurbished for a number of different organisations to have their headquarters there.
Lot 14 could become as famous as Area 51, Fred.
Oh, it could, yeah. Maybe for different reasons. Well, maybe the same reason. Who knows?
You don't know.
So yesterday, our time as we record this on the 20th of February, yesterday was the day that the Prime Minister went to Adelaide and with the Minister for Science, Karen Andrews, cut the ribbon to open up the new Australian Space Agency's building. It's the remit of our space agency has always been the same pretty well ever since it was founded, which is to support Australian ventures in space, and by that it principally means industrial and technical know-how, the small companies that can provide services or actually make bits and pieces for rockets. That is what it's all about. It's about nurturing these companies. It's about providing an umbrella organisation so you don't get little startups all over the country doing the same thing. It's very much got an industry focus. So most of its budget, in fact, goes in things like supplying grants and making inroads into providing companies with the backup that they need. There's a new initiative actually just been launched, which is all about inviting startup companies and organisations like that, companies with good ideas, to apply for funding to the Australian Space Agency. So that's its focus. Its focus is in nurturing Australian industry. At the moment, so the world's space budget at the moment, and this is the commercial space budget, is round about $400 billion. We in Australia have about 1% of that. I think it's about 3.6 or something billion. This is Australian dollars. In fact, actually, beg your pardon, it's 3.9 billion. That's the current space industry here in Australia. The government wants to see that grow to something like 12 billion within the next decade. So that's a tripling of what we do, and a tripling of the jobs as well. There's about 10,000 people employed in the space industry here in Australia. They want that to go up to 30,000 by 2030.
That's amazing. I knew there was a big number in terms of future jobs, but that's incredible.
Yeah. The space agency itself, I have to say, is pretty lean. It has a staff of 20.
I wasn't far off then, was I?
No, you weren't. It's not like NASA.
And they still only have 2 desks.
They share the desks. So it's very much an organisation that facilitates things. That's certainly the way it has been seen and the way it's been set up. I know many of the people in the Australian Space Agency, and they are absolutely dedicated to this. They're very switched on. There are not many things that you can talk about in the space world where they say, "Oh, I hadn't heard of that." They've heard of most of it. So they've got their finger on the pulse. They are across much of the industry. Eventually, there will be space launches from Australia as well, probably down in the south, in South Australia, but also Australian Equatorial Launch is a company that wants to launch from Cape York, which is right up in the north. And of course, that's not too far from the equator, which gives you an advantage when you're launching spacecraft into a standard orbits.
Yeah. And look, I know they listen to us. They share our podcast on their Twitter feed, which we really appreciate. So I hope they understand my jibes are tongue in cheek. Sometimes, but no,
it's a bit rough.
Great news. It's a
bit rough when you've got to explain that. They're tongue in cheek. Don't worry, it's all right.
Some people don't get the Australian sense of humour, but I'm hoping Australians do.
Well, so, there's some. Yes,
then again, we're talking about my sense of humour. I was telling my wife a joke last night, and after I finished telling the joke, because I used it on air, I then had to explain to her why it was so funny, and she went, "Oh." I would have had more luck explaining it to a cat. Where's Mandu, by the way?
Yes, yeah, well, he gets all the jokes.
Yes, of course he does.
He's consumed with mirth most of the time.
With the great news that the Australian Space Agency has been officially opened, we also hear some news about Virgin Galactic, because they've moved house. They too have taken up residence at their official New Mexico spaceport.
That's right. So what they've done is moved the hardware, basically the principal hardware, which is the mothership and the space plane, VSS Unity, which is what will be used to fly fare-paying passengers to the edge of space. And that brings us a step nearer to that commercial service. So it's been in the Mojave Desert where these vehicles have been built and tested so far. All the spaceplane tests, which we've talked about, have been over the Mojave Desert. But now moving it to New Mexico, to the basically the Virgin Galactic Space Terminal at Spaceport America, which is not very far from a place called Truth or Consequences. Great name for a village.
Yeah, it is.
So that move really signals the start of the final proving tests for the space plane and its mothership. In fact, the journey itself, it's a 3-hour trip, I think, at high altitude from Mojave to the Spaceport America in New Mexico. And so that journey itself was part of the evaluation process, because it's a 3-hour trip, which is much longer than the space plane is, and the aircraft are normally operational. So it gives you a new mode for environmental evaluation. So what they're going to do when they get to Spaceport America is do lots of final checks. Probably we'll see more test flights, but we'll also see perhaps what you might call the refinement of the visitor's experience. How it will all come together with people going through the spaceport, which itself is a magnificent building. I've been there, as you know. How you feed visitors through that process, how you train them for their experience of space, and how you give them the very best experience when they're actually on the trip. So we'll see lots of future activity. I think it's the press release that came, says the relocation of VSS Unity to Spaceport America enables the company to engage in the final stages of its flight test program. It'll begin with a number of initial captive carry and glide flights from the new operating base in New Mexico, allowing the spaceflight operations team to familiarize themselves with the airspace and ground control. Today, we realized the next step in that dream by bringing our beautiful spaceship to New Mexico. We still have significant work ahead, but we're grateful to all our teammates who've made this day a reality. That's George Whitesides, who's I think he's the CEO of Virgin Galactic. Yes, he is. So it will be interesting to see what happens next. And I think this sort of marks a new phase for Virgin Galactic. Hopefully we'll see fair-paying flights before too long.
Yes, they've had to delay it. They've had a couple of issues historically, and you don't want to rush these things. You want safety to be number one, and that's slowed them down a bit. But no official date yet, but it can't be too far away. That's right.
Just one footnote to this, Andrew, is that there are 2 more space planes which are currently on the stocks, which are being built. So one of them has the second one's already is. I think we saw pictures of it earlier in the year. It's already in one piece. So all its components have been put together, and there's a milestone that you celebrate when you're building something like that. It's called the weight on wheels milestone. So it means everything's put together and it stands on its own wheels, which is great.
Yes, indeed. Very exciting news, and we'll look forward to their first flight in the not-too-distant future. This is Space Nuts, episode 190, with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, our YouTube numbers have absolutely skyrocketed. They've gone Virgin Galactic on us.
That's good to hear.
They've gone from 1,004 to 1,006.
Well, come on, Andrew.
Unbelievable.
Staggering.
Yeah. But if you would like to follow us on YouTube, and actually a few people have messaged me to say, I'm going to do that, that's great because, I don't know, something about the numbers. Hugh, our producer, understands all this stuff. I leave it all to him. But, the more numbers, the more interesting we are to YouTube, or something to that effect. It might have something to do with advertising. I'm not sure. But if you would like to follow us on YouTube, just go to YouTube and do a search for Space Nuts Podcast, and you'll find us, and you can subscribe, and you can hear everything there, as well as all the other podcast platforms that exist in the world. I think we're on just about all of them, Fred.
That's good to know.
Yeah, I know. It's exciting. They mustn't have much material. Anyway, let's get into some questions, shall we? We will firstly go to a question from Mark Mobbs. Hi, Mark. Thanks for your question. He says, I've been trying to get my head around the size of the Milky Way and the visible universe and what astronomers can see or understand at different distances out into space. Are you able to put it into perspective for me? For example, I read somewhere that if you shrunk the Milky Way down to the size of a grain of sand, the visible universe would be, in relative terms, about the size of a football oval. I'm not sure if this is correct, but it got me thinking about the observations we make from Earth. What would be a tiny dot in the middle of a grain of sand? For example, how he's been very elaborate with his descriptions here. For example, how far out are we looking when we look at the stars in the night sky? How far out into the universe are we currently searching for exoplanets, and how far out can we determine the composition of distant planets? He goes on to say, I'm trying to understand just how much of the universe we really understand in detail, or probably more accurately, how much of the universe we really don't know much about in any detail. I assume we have good observations and science from within our own galaxy, i.e. within the grain of sand, but we have progressively less information detail the further out we go into space, until we reach a point where we can observe distant galaxies but really don't have the ability to carry out any detailed observations on them. Love the podcast. Cheers, Mark. And that's all we've got time for this week. I do love that joke, though. Look, he's brought up some interesting points, and I'm sure it's I guess the further you want to look, your time scales vary significantly, and it becomes more and more difficult. I imagine he's right about that.
Yeah, that's right. The further you're looking, the harder it is. But there's certainly some things we can say about this in terms of trying to understand the scale of things, and that really is the big problem in astronomy and astrophysics. We have such a huge distance scale that it almost beggars belief. It's certainly mind-boggling.
Is he right about the football field theory?
Yeah, but that will be about right. I haven't done the calculation, but it's that kind of thing. A grain of sand, the horizon of the universe being the edge of the football field, and the grain of sand in the middle of it. It sounds, if anything, that sounds like you're making the football field too small. I'd need to do the calculation on that one. Just to get a proper view of it. Maybe I'll do that before our next catch up.
Well, it's all relative, isn't it? Because some people will be thinking of the Melbourne Cricket Ground, some will be thinking of Candlestick Park, some will be thinking Wembley Stadium. I mean, which one? So, they're all different.
Which one is it? That's right. No, indeed, that's quite so. Let me, but there are some things I can say, and so. Mark's point about how far out are we looking when we look at the stars in the night sky? Is it just the distance of the grain of sand? In other words, our galaxy. It's not even that. With the naked eye, the stars we see are within a few, they're within certainly within 1,000 light years or thereabouts. And that is just our immediate vicinity within our Milky Way galaxy. And that's partly because we're in the disk of the galaxy. The disk of the galaxy is a very dusty place. You don't really see you don't really see through the dust. You can with certain types of telescopes, infrared telescopes and radio telescopes. They reveal all that. But the stars in the night sky are really very, very close. Just let me tidy up just a couple of questions. How far out into the universe, in other words, the universe beyond our Milky Way, are we currently searching for exoplanets? Well, the exoplanet search is specifically for stars within our own galaxy. I think there might have been one detected in the Andromeda galaxy, which is our nearest big galaxy, but basically you've got to be looking at nearby objects to discover exoplanets, nearby stars. So actually most of them are very local. They're within 1,000 light years or so. How far out can we determine the composition of distant planets? That's, again, something that's relatively nearby, because to do that, if you're looking at planetary atmospheres, and we'll certainly do more of this with bigger telescopes, you're not just looking to try and see evidence of the exoplanet. You're also trying to break up its light into a spectrum to see what's in that spectrum, and that means you're diluting the light still further. So you really are talking about nearby and relatively bright objects, typically within 100 light years. I think it's a really good comparison that brings home what these distance scales are like. Is if you think about our own galaxy, the Milky Way, we're used to seeing pictures of spiral galaxies. Ours is one of them. It's something like, it's being revised as we speak, but it's roughly 100,000 light years in diameter. Now, that really doesn't mean very much. The way I tend to draw the comparison is if you imagine a portrait of the Milky Way, a beautiful spiral of galaxies, you can imagine that as a picture in a book or something like that. And indeed, Cosmic Chronicles has got things like that in it. Just a plug there, I couldn't resist. All right, now you take this picture of the galaxy and you blow it up to be the size of the Earth. So you've got a portrait of a galaxy that's 12,500 kilometers in diameter. It's big. It's that's a very big picture. And then you can ask the question, how far apart would the Earth and the Sun be on that scale? In other words, the scale of the solar system, or the inner solar system. And the answer is, if the galaxy was scaled to be the size of the Earth, the separation between the Earth and the Sun on that scale is 2 millimeters.
Oh, wow.
So, what's that, a 1/12 of an inch or thereabouts.
Yeah.
So that's telling you just how much bigger the scale of the galaxy is than the scale of the solar system. And then Mark's comparison that to compare the scale of our galaxy with the scale of the universe, yes, you're talking about something similar, a grain of sand to a football field. So it really is, the distance is really the killer here. And it astonishes me how much we do know when we're talking about these big distances. So you're quite right, Mark. You do get less information as you go further out, but we're looking out. When we look out into the football oval-sized space, you're also looking back in time, and we can learn a lot by looking at early galaxies. We can see their structure. We can work out what their chemical elements are like, what sort of shape they're in a galaxy like that. But the details, the further out you go, the more blurry the details become.
Yeah. Now, you said we look at the night sky and we basically see our own galaxy. We see the stars within, but we can see other galaxies, can't we, with the naked eye?
That's correct. We can. But generally speaking, it's the neighbouring stars. Yeah, I was going to say, when you look at the Milky Way, most of the stars in the Milky Way are fairly nearby, but there are parts of the Milky Way, certainly in Sagittarius, where you're looking at the bulge of the galaxy. That's the central region where in the nucleus of the galaxy it's sort of got a bulge shape to it. Those stars are 25,000 light years away. So you're looking there, at something that is, well, we're about halfway from the center to the edge. So you're looking over a distance which is the quarter of the radius of our galaxy. And as you say, there are different galaxies that we can see with the naked eye. There's not many of them. The two Magellanic Clouds here in the south, the large and small clouds, I think the large cloud is about 165,000 light years away, the small cloud 200,000 light years away. And then finally, most people, the most distant object they can see is the Andromeda Galaxy, which is about 2 million light years away. That's in the constellation of Andromeda. But they're rarities. When you look at the night sky, most of what you see is very nearby.
Yes, indeed. All right. Thanks, Mark. Hope we managed to answer most of your questions. There were many, but we appreciate it. Let's move on to a question from Bob Brown. Hi, Andrew and Fred. Love your podcast and the books. Bought Cosmic Chronicles and Parallax last year. Good reads.
Great stuff.
Which one was better, Bob? Anyway, I have a question. This is of a similar ilk. What/where is space? I know the current accepted start of space is 100 kilometres from Earth's surface, but surely real space starts at the end of the exosphere at about 10 kilometres. Anything below that level is in the Earth's gravity field, and surely where there is no gravity field of Earth, that has got to be the definition of where space begins. Everything below that is still in orbit and will over time fall to the ground, and therefore it really cannot be said to be space, surely. Otherwise, why not say space begins at the Earth's surface? Because Earth's itself is in space, is it not? I understand the current boundary is where aeronautics ends. I think that's what he means. That being when a plane cannot fly because the atmosphere is too thin. That would be the ceiling of the aircraft, I imagine, and that varies. That being when a plane cannot fly because the atmosphere is too thin, but it is still atmosphere above that point, is it not? I hope you can clear this up for me. I still remember being told at uni that the only people who have really been to space are all the Americans that went to the moon, I'm guessing. Although we were talking about this last week, and we discovered that the moon is passing through the Earth's atmosphere. So
yes, that's right.
It's a difficult one in some respects.
Well, it is and it isn't. There's a few misconceptions in Bob's question. Let me just start at the end. At the moment, the total number of people who've been in orbit around the Earth, and that's a pretty good definition of space if you're in orbit, is more than 500. So that's quite a lot. And a lot of those have been people who've been on the International Space Station. But so Bob's initial, what he's saying at the beginning is correct. the normal definition of where space starts, it's something called the Kármán limit, is 100 kilometers above the surface. And that is all about aeronautics. That's right. It's where the atmosphere is simply too thin for any kind of aviation type, controls to be of any use. No good moving your ailerons up and down or your elevators or whatever, because nothing will happen.
Yeah.
10 kilometers is an interesting level that he describes as well. 10 kilometers is actually, it's not really the start of space, but it's where most jet aircraft fly.
Yes.
And at that height, you are almost in space. You're above 75% of the atmosphere. And so above that are the outer layers of the Earth's atmosphere. I often think when I'm sitting on a plane, I seem to do that quite a lot. You're almost effectively in space. There's still atmosphere above you, but and of course you're supported not by orbital considerations, but by the fact that you're airborne. The air is carrying you. But it is still extraordinary technology that lets us do that. So the big misconception I think that Bob's email suggests is the effect of gravity. Now, the Earth's gravity field goes to infinity. It's not something that stops in space. We talk about zero gravity in space, but it is a misnomer because the gravity is still there. When you've got people in orbit, at a height, say, well, the International Space Station, roughly 400 kilometers above the Earth's surface, it's in orbit around the Earth. The gravity that they're feeling is very similar to what we feel on the Earth's surface. It's not really very much different. But the reason why they're weightless is because they're falling towards the Earth all the time.
So you get that effect of
you're just falling. Yeah.
So you float because
that's right.
Effect.
What stops you hitting the Earth is this forward motion of 8 kilometers per second or so, which means that as you fall towards the Earth is receding away from you.
So you maintain altitude.
You maintain exactly the same altitude. That's right, and that'll just keep on going. But the gravitational pull is the same, effectively the same as the surface. It does drop away once you get to the Moon. It's fallen away significantly. In fact, there's a point between the Earth and the Moon where the Moon's gravity becomes dominant. But if the Moon wasn't there, you'd still be feeling the pull of the Earth's gravity. It will be much, much lower by that stage, at that distance. But it does. Gravity is a force that goes on effectively to infinity, although in real terms, it diminishes. So that the further away you are from something, the less you feel of it. I should point out, though, that when when you're navigating a spacecraft like New Horizons through the solar system, when you're calculating its trajectory, you've got to take into account not just the gravitational pull of the Sun, the biggest object in the solar system, but all the planets as well. Jupiter, Saturn, in order of mass. Jupiter, Saturn, Uranus, Neptune, and then going down through the Earth and Mars. All those planets make their contribution because they've all got gravity, even at the distance of New Horizons. So you have to take them into account. So the definition of where space begins, as Bob suggests in his email, is a pretty loose and woolly one. And really that Kármán limit is one that has been adopted purely as a matter of convenience. Because you can say it's where, in fact, actually below that, well below that, the aeronautics stops. And your movements in space are dictated by orbital mechanics, by the ballistic forces. So,
So I guess the one question he's thrown in there is, if we're standing on the surface of the Earth, are we in space?
Yeah, in a sense we are, because the Earth is an object that that exists within space. But from a practical point of view, you wouldn't say that the base of our atmosphere was the same as the region 100 kilometres above it, where there's virtually no atmosphere at all.
We're not stuck in a vacuum.
That's right.
Except for the dust that you take from under the bed with, whatever. Vacuum cleaner. All right. So essentially, it's a bit of a fuzzy one. So we define these things for convenience sake more so than anything.
That's correct. Yeah, that's right.
All right. Bob, thanks for your question. Love your address. Harvey Bay, Queensland, Australia, Earth, Solar System, Milky Way, local galaxy group, local galaxy sheet, Virgo supercluster, Lanaka, is that what he's saying? Observable universe, cosmic microwave background, the universe, and then question marks. I will add multiverse just to keep it interesting, Bob. I used to do that.
You're all mad.
Crazy, yeah. Well, that's why we're space nuts, Fred.
Exactly. Yeah. That's right.
Thanks, Bob. Appreciate your question. And that just about wraps us up, except to say don't forget to visit the Space Nuts shop. It's on our website, bitesz.com/spacenuts. That's BITESZ. Log on and have a look around, see if you buy a T-shirt or a book or a T-shirt. I think that's about the range of our products at the moment, but we'll build on them. We're talking about mugs and other things going forward. We'll see how we go with that. Next week, I've got a job for the audience. I want someone to come up with a title for my new book.
Yeah.
So next week, if I remember, I will give you a basic synopsis of the story without giving too much away, and see if someone can come up with a title, because I honestly can't. I'm really struggling with it. And I've talked to my brother about it because he's done a wonderful cover for me. He said, "Oh, call it this." And I went, "No, but that's not what it's about." He said, "Doesn't matter. It's a great name." I said, "Yeah, but that's not what it's about." So I'm going to challenge the audience to come up with a name or a title for my book. And I guess if I like one that I ultimately decide on, I will give that person a credit on the inside cover. How's that?
Ooh, now there's a treat for you.
Good stuff. Get your name in a book. We'll see how that goes. Anyway, I don't usually have trouble, but this one's eluding me. Anyway,
you're lucky. You get to choose your own book names. I don't.
Oh, I don't. Yeah, well,
it's always the publishers. Yeah. That's why everywhere else in the world other than Australia, Cosmic Chronicles is called Exploding Stars and Invisible Planets.
There you go. I don't have that trouble because I'm the publisher.
Yes, I know.
Yeah. All right. Thank you, Fred, as always.
It's great to talk, Andrew, and I look forward to talking again next week.
Good fun. I'll catch up with you then. Professor Fred Watson, Astronomer-at-Large, and from me, Andrew Dunkley, thanks again for your support and for listening to the Space Nuts podcast. Hope you enjoyed episode 190, and we'll catch you again next week.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at bitesz.com.
This has been another quality podcast production from bitesz.com.